Hi everyone, I'm gonna be doing question one of week three homework. So, today we're gonna try to solve this circuit problem and like find the total voltage across the first resistor R1. And I drew a quick sketch here of the circuit, and as you could see, we have a total voltage source at the bottom of the battery and two resistors at the top. And they're both hooked up at a single line, which means it's a series circuit. So before we jump into like the math, we can break down what all of these letters really mean. So first we have V, which I nope, we have V, which I wrote here. And so V is the total voltage or like the source voltage from the battery. And voltage is basically like the electrical pressure that pushes the charge through the circuit. And its SI unit is in volt, which is uses a capital V. And then next we have R1 and R2. And so these stand for the resistance, and resistance is how much a component fights or slows down the flow of electric current. And the SI unit for resistance is in ohms, which uses the Greek letter of omega. And so now we have I, and I is the electrical current. And I would have drawn like a little diagram to show like I moving through the um current, but yeah, so I is the electric current, and current is the actual rate at which the electric charge flows through the wires, and its SI unit is in amperes or just amps. And then finally, we have V1 over here. And so this is the voltage drop across just R1, the first resistor, and it's how much electrical energy is used up by that specific resistor. And just like the total voltage, its SI unit is also in volt. So step one to figure out what's happening at resistor one, we first need to figure out the total current flowing through the whole circuit. So, um, to get that, we need the total resistance first. So, because these two resistors are combined in a series, connected in a series, that means they are a single line, and so the current has to flow through both of them, one after the other. Just so that means we could just add them together to get the total equivalent resistance. So that means our equation would be the R total is equal to the sum of R1 and R2. And so we don't have the actual numbers yet, so we will just keep that as is. So that's step one. And now for step two, we can use Ohm's law. And so Ohm's law is basically just V is equal to I times R. And so to solve for I, we can just rearrange it so that its I is equal to V over R. And since we want the total current in the circuit, we can use our total voltage, V, and we could divide it by the total resistance we just found in step one. So that would be you substitute that in, it would be I is equal to um V over R, the sum of R1 and R2. So it would be like that. And so now we have a nice little expression for the total current flowing through the entire loop. And so for the last step, we need to find the specific voltage across just R1, which is, as I said, is called V1. So in a series circuit as we have here, the current I is exactly the same everywhere. So it doesn't split up. So the current is just growing through R1. This is just the exact same current we just found. So we can apply Ohm's law again, but just for this specific um resistor. So it would just be V1. I'm just going to reuse this equation I have here. V1 is equal to I times R1. So now all we have to do is take our current expression here and substitute it into this equation. So that would make it combine these two equations. So substitute that in, and we would get V1 is equal to V, wait, no, V over the sum of R1 and R2 times R1. And if we just rewrite it slightly to make it look clean and match our multiple choice and options, we would get we would group the resistances together like so. V1 is equal to R1 over R1 plus R2 times V. And so that matches our third option on the page perfectly. And it shows that the voltage splits up proportionally based on how big R1 is compared to the total resistance. So thank you for watching.